Hopefully you guys are going to do well. Okay. All right, let's take a look at number 1. It says, compare and contrast the below dilated triangle. Now there was something here that was missing that should have been stated, and it should have told you which one was the original image and which one was the new image, because that does change the either if it's an enlargement or if it's a reduction. So that's fine. If you said A, well, the small one was A and the big one was A prime, that would be enlargement. If you did reduction, then you would have said the big one was the original one, small one is the new image. So that error, I fixed it on the test for today. So make sure you read carefully. Okay. So
and they're both equilateral.
if they're not equilateral, they are right angle triangles, and this one has side lengths of 6 and 6. This one has side lengths of 2 and 2, so that would be not equilateral. That's called.
Well, I mean, isn't the large side? Did I do that wrong? I counted it diagonally.
Okay. Triangle with two sides that are the same is called.
It's an isosceles.
Isosceles. Just want to make sure that we clear that. Equilateral would have been they all measure 6.
What is the large side?
The large side, you'd have to do Pythagorean theorem to figure it out, but you don't need to do Pythagorean theorem to figure it out. Yeah, you didn't have to figure that part out, because you could have just went off of those numbers. Okay. Now, be careful here. You're going to do this on the test. I've already fixed the test to make sure it says which one is the original and which one is the new image. Okay. You guys are going to have to make sure you tell me the scale factor. So if it was an enlargement, we would use the big numbers over the small numbers. Notice I have both of them are 2s on the small one and both of them are 6s.
So you need to find out what is it enlarged. It's enlarged.
What's the scale factor? So if it's an enlargement, you got to make sure you remember. You got to do the new image numbers over the original image numbers. Yeah, 6 over 2 reduces to be 3. So the scale factor would be labeled with the letter K equal to 3. Now that's if the image was an enlargement. Does everybody understand that? If it would have been a reduction, you have to do the original images, the sides, those sides, over the new image sides, 2 over 6. Now, does it really agree? I'm only writing it once because it's an isosceles triangle. So if I knew all the sides, then I would do each one and make sure the corresponding sides go with them. Yep.
So it's
And
reduction of 1/3.
if it's a reduction, the scale factor would be 1/3. Yeah. Or if you do 1 divided by 3 on the calculator, you get 0.3. Make sure everybody has a calculator. Is there anybody that needs one? Raise your hand. And pass that across to Alexander. All right, everybody has a calculator? Yes? Okay, good. All right, so when it says compare and contrast, you guys would be able to tell me if it was an enlargement or a reduction. You'd have to be able to tell me the scale factor as well. Are the triangles similar? You guys remember how to state if the triangles are similar?
Same means the side angle side.
Either side angle side, or angle. Yeah. And in this case, it'd be side angle side. Yeah. So you got to make sure that's going to be something that you're going to do on the test a lot. So everybody, we're going to go through that a couple times, so make sure you ask questions, okay? Does everybody understand that the scale factor? It all determines if it's an enlargement or a reduction. This one, K equals 3, that would make that dilation an enlargement or a reduction? Enlargement. This one is an enlargement, okay? And it's funny because I just ordered pictures from Costco, and some of the pictures I blew up, some of them I made wallets. Right? So that's where you're going to do those types of enlargements and reductions. When you guys get older, if the proportions don't match and you're trying to make a picture into a wallet size or you're trying to fit it into a certain size frame, you got to make sure the proportions match. If they don't match, there's a problem in here where it shows you what happens. Okay? All right. So, and the 1/3 was a reduction. And can everybody remember that you need to use the letter K to tell me that's the scale factor? K means that's what I'm going to assume that K equals the scale factor, okay? All right. Everybody okay with that one right there? All right, let's go to the next one. Okay, on the next one. This one you had to do Pythagorean theorem. It was asking you to find the scale factor of 3 to get the length of, notice it's writing the letters with 2 tick marks, so that's A double prime, B double prime, and C double prime. It also gave you A prime, B prime, and C prime, and it already mapped it on there, but that was just kind of to throw you off, okay? You were supposed to dilate the original image triangle ABC by a scale factor of 3 now. That's what you were supposed to answer. So ABC, coordinates for A, coordinates for B, coordinates for C. And if you notice, this side length right here and this side length right here is technically supposed to be at 3. This side measures 4 units on the original figure. Yep. And then over here, this side here is from 2 to, and I believe it's supposed to be at 4. That side here measures 2 units total. So it's asking you for what's the length of B prime, A prime. What's this length after you do the scale factor of 3. So when you do the scale factor of 3, you realize that these numbers are also going to increase by a multiplication of 3. Now you could get the coordinates. Remember, if you know the coordinates, you can just multiply each coordinate by the number 3 to get the new coordinates of it. But in this case, we're going to end up getting a bigger triangle. And whatever this side is, and whatever this side is, it's all being multiplied by 3. This side measures 4. This side measures 2. Now I need you to stop me right now if you're not sure. How am I getting the 4 and the 2? Right. Does everybody understand the question is asking you about triangle ABC? The other part's kind of there to throw you off. All you were supposed to do was just focus on ABC, okay? You notice that B, the coordinates for B are 2, 1 for B? Yeah, okay. The coordinates for C are 2, -3. 2, -3. You can use the coordinates and multiply them by 3 to get the new coordinates of the figure, if you want to. But in reality, all you really need to do is worry about what's this side measure of B to C. And if you look at the coordinate from 1 to -3 on the y-axis, you agree that's 4 units away from each other? Here's 1, right? Here's 1 unit. 2, 3, 4 units. That's the distance of that side. Does that make sense?
Yeah.
Okay.
So all you
Go ahead.
do is go from B
B
down
to C. Okay, that's what you're going to answer. B down to A.
Yeah, but by doing that, you go from B to C.
Get this side and then get this side from C to A, and then do the Pythagorean theorem. Okay. Now remember, this side, whatever it's going to be for C, is also going to be multiplied by the scale factor, right? But you notice I don't know what it is right now? So it's going to be 4 squared plus 2 squared equals C. When I find C, I'll just multiply it by 3. Yeah? What's 4 squared? 16. Plus 2 squared is 4. Everybody agree? Okay. What's 16 plus 4? 20. Square root of both sides, so everybody go ahead and do the square root of 20. Approximate 4.47. Okay, use 4.47. Now multiply that by 3.
13.41.
3 times 4.7 is 13.7. 13.7. Everybody here should be following with me. Some of you guys are kind of just sitting there, not typing in and checking any of this. 3 times 4.47 would it be?
I got
13.41? Okay, 13.41. A couple people will agree. So 13.41 is the length of A double prime, B double prime. Okay?
So, in all reality, all you had to do was take AC, CB, run out the question, you didn't have to look at the
The rest of this stuff was kind of to throw you
and
off.
then you could have just done that and multiplied by 4.47.
Yes. And now remember, the
Okay,
scale
so in
factor.
all reality, I did it right by just doing that.
Right. As long as you got to make sure though that you did have to use the Pythagorean theorem. You understand that part? Because this is a right triangle right here, the little one.
Yeah, but that's not what the question's asking for.
No, but you had to use Pythagorean theorem in order to get that side. If you don't do that, you can't get that number.
But I just did it.
But here's what I'm trying to explain to you. In order for you to get B double prime and A double prime, you need this side length, which is, what did I say, 4? And this side length, which is 2.
But it says that is a problem.
It's all in the problem.
Right. Oh, okay, I'm sorry. I apologize, thank you. Okay, all right. On the test, it's not going to give you that one. Oh, I can look at that. Sorry, I didn't catch that. You did catch me off guard on that one, so you are correct. Thank you. But on the test, I'm not going to give you that VA number. Okay? So you are going to have to do that Pythagorean theorem. So you did correct me that you are correct. I didn't catch that. You okay?
Yeah.
All right. But on the test, I'm not giving you that. Okay? All right? So thank you for catching that. I did notice that. I'm gonna have to fix that up. Don't give them that. You were correct though. How you did? All right. Number 3. Dilate the shape by a scale factor of 2. So that one was pretty simple, but the only thing that was difficult about it was you had to get these coordinates here.
Of like 85 different numbers.
Yeah. So if you notice these two that I labeled right there, those coordinates are -2, 0,
Might as well start at the top of the table.
and
Is it okay if I only did half of those and then kind of ad-libbed the...
hopefully that's fine. What you could do is you could do these two, and you could do these two, and I think with those 3, you should be able to get the rest of it. Yep. You don't need to get all of those points, because at that point you're going to start to be able to connect them. Yep. Does that make sense? So that's just the final.
Yeah,
Yep.
like 4.
So I would say half of the points then. You don't have to get all of them. Yep. So the one I just gave you, -2, 0, and -3, 0. Okay, do you guys see how I'm getting those coordinates? Yeah? Okay. And then the other ones I would get would be these corners over here, and those were -4, 1, -4, 2, and then -3, 3, and then -2, 3. And when I do the scale factor of 2, does everybody understand I'm multiplying everything by 2? Don't sure me, because you're about to take this test, and I'm not going to answer your questions, okay, after I give you the test. So don't sure me if you're just saying it, you don't know what's going on, okay, because that's right there. This is where some of you guys, if you take this too lightly, and I tell you you didn't pass the test, and you have to retake this whole test, that's on you, okay? And I don't want you to come to me when the test is in your hands and you had the opportunity to be serious and focus and you didn't. I'm sorry. You're going to have to redo that test. Plus, you're going to have do extra work on it if you don't pass it. Okay, so I'm trying to help you here. Okay? All right. So I'm assuming then everybody understands you just multiply the coordinates by the scale factor to get the new coordinates. Now here's the thing, you have to draw the new image. So, -4, 0, that would be, -4, 0 would be right here. Then this one would be -6, 0, that would be right here. And then this one over here would be -8, 2. -8, 4. So -6, -7, and -8's right here. -8, 2. -8, 4. So you're kind of already, Justin, this is kind of what you were telling me. Once you get those, you already kind of have the idea of the basic shape there. Yeah?
Instead of it only moving 1 point to the next point, now it moves to 2.
Now here's the thing though, if your points are off on your drawing, that's where you would be wrong. So just don't take it lightly. This is easy. You can do this. Okay,
So
you can do
on
that
the
fairly
test, you
quick.
might as well
Just
do
take
all of
a
them.
few extra seconds, Just don't get too anxious here, and then you start getting answers wrong, and that's where people are going to realize that, hey, I'm not going to have any mercy, and I'm going to say I'm sorry.
How come you couldn't go with a triangle though?
I do have a different figure. It's not the same one.
Well, that's good because there's 8 points on this one.
Yeah, I know. I didn't make that one. Okay, this one. On the test, I changed it. I actually gave you another image because I realized that some of you guys might end up drawing too big of a shape, and then you try to dilate it, and it's not going to fit.
Yeah.
So
Just take my word for it. It takes up more than the thing.
yeah. So what I did is I made number 3 and number 4 pretty much. I gave you the image because I realized some of you guys are going to get a little crazy.
Okay, so
So don't worry about this one on the review, but it's exactly. I made it exactly like this one.
okay,
Okay.
and easy peasy lemon
Uh-huh.
I did it, and I was supposed to make it larger. And
And,
I'm like,
and you didn't,
"Oh,
and I knew it, and I didn't think about that. And that people were going to choose figures whatever they wanted, and then I realized, man, some of them are going to get
This is a bad idea.
super anxious, and they're going to make it so big that
And
it's
draw the Batman symbol on there.
Have a second piece of paper
But,
stapled with your paper.
So I decided I'm going to choose the figure for you, so that it fits no matter what. Okay. All right. So you guys understand 3 and 4 then? Yeah. Okay. Let's go to this one right here. Okay.
Number 1.
I didn't catch this. It says show there's a sequence of one or more transformations that can carry one rectangle onto the other. Now here's the problem. I didn't state which one was A and which one was A prime, so I fixed that on the test. Okay. And then I also fixed something else because 3 over 4 should equal 24 over 56, right?
It's
And
like
they
1,
don't.
3, 3, and 2.
That's supposed to be a 32. So everybody fix that? So I fixed that. I fixed that on the test as well. Okay.
So do you want us?
So now it should be, instead of 24 over 56, it should be 24 over 32. And when you check that, 3 over 4 is 0.75, right?
0.75.
Oh, I did
Yeah.
it the other one.
And 24 over 32 is 0.75. Those are similar figures, right? Yeah? Now, I want to ask you something. I forgot to do this. I forgot to tell you which one was the original and which one is the new. Can you tell which one is the original now that I put it in there?
A.
Hey. Is that an enlargement or reduction?
Enlargement.
Okay. What? Do me a favor. Take a minute right now, and I want you to tell me what. Figure out the scale factor.
Yeah, it's a dilation.
It's a dilation, and the scale factor is 8. Now, if you're not sure, it's the numbers of the new image, 24 and 32, and you put them over the numbers of the original image, but they got to correspond. So 24 should be over
3
3,
and 4.
32 should be over 4, and those numbers should be identical. Yeah? 24 divided by 3 is 8, and 32 divided by 4 is 8. That, your scale factor should always be the same. Yeah?
Is it alright when I was comparing them, I put 4 over 3 and 32 over 24?
4, yeah, that's fine. 4 over 3, and you should still get the same decimal value. Okay?
So it doesn't really matter which bigger
Order?
or smaller on top,
Yeah.
bottom. It doesn't matter. You're going to get.
That's
the
when
same
you're going to
decimal.
check to see if they're similar. Okay? But if you're checking, if you're going to write me the scale factor,
You got to make sure they're.
you got to make sure they're similar, the ratios are proportional, okay? And then if it's an enlargement, you got to make sure you do the image, the sides that are the new image over the sides that are the original, because the original should be smaller numbers, yeah? If it's a reduction, then just do it the opposite
So you
way.
put the pre-image on the bottom,
Right,
and then the original on top.
that's if it's a reduction, because that's going to give you a smaller number. Okay? Alright. Just remember, enlargements are always numbers that are less than 1, bigger than 0, or enlargements are always numbers bigger than 1, right? Reductions were always numbers that were less than 1, which were decimals or fractions, right? Okay? Alright. Alright, so you guys are going to have a lot of scale factor. You're going to have to give me scale factor. You're going to have to tell me, are you using angle, or are you using side, angle, side, or side, 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 to prove that they're similar, okay? Remember, you guys, how to check proportionals, the sides, if the sides are proportional. Okay, so on this one, solve for x, and here what you could have done was x over 14, and you should have set it equal to 88 over 84. All right.
What if I set it up as an algebraic equation?
Well, it's got to be set up as proportions because this is a dilation of something. Yeah. Okay. And your answer should have been x equals 14.66 repeating. You guys already understand the cross multiplying of it?
Yeah, I got this.
So on that right there, though, you got 84x equals 44 times 88.
Correct.
And then,
84x equals 14 times 88.
yeah,
Okay, so that would be 14 times 88. Give me that number.
1,232.
Is that right? 1,232?
Yeah.
Yeah, okay, so then just divide by 84,
Okay.
and you see how I get that number?
Yeah.
Yeah. Remember the handout we did with all the proportions? Okay. All right, for the next one, what would you set up?
30 or x over 35.
Okay, x over 35 is good. Now you got to set it equal to, be careful.
336.
Yes, 336 has to be on the top. 245 has to be on the bottom. Does everybody understand that part? All right. And that one will give you an answer of x equals 48. Yes?
Yeah.
All right.
245 divided by 11,706.
Hey, I should have done these at home. These should have been pretty easy. Okay. All right. Go ahead and finish that. Now, you guys that are not getting this work done, again, I'm moving on here right now, okay? Number C here. This one, on the test, I have to make sure I label the lettering correctly. So on the test, I did put the letters that corresponded there. And I made the similarity statement of the triangle. Remember, I kept telling you guys, don't forget when you have to write the letters that are similar to the other letters. They can't be just in any order for the triangles. Okay. So I noticed I didn't put that on there. So this one, if you set it up as 4/6, then you wrote x over 22.
72.
20. Oh, 72, thank you. X over 72.
And you get 6x.
6x equals 4 times 72 is 288. Divided by 6, x equals. You guys need to make sure you're showing me your work. That's not that much work. Yeah, when you're setting your report sheet. All right. Let's move over to the next one. Now, those of you guys that are not getting your work done, I'm going to be moving through these fairly quickly. Okay. This one is asking for show that there is a sequence of one or more transformations. Do you notice that the triangles are 11, 12, and 15 on the inside? And on the outside, 99, 135, and 108. Notice the smallest side is on this side on the big one, and then the small one is on the other side.
Yeah, so it did a
What's that called? Transformation? Reflection. Okay, that's a reflection.
Would it be a reflection because it's on the same, it's in the same location?
It's in the same location. That a reflection just would be that line of symmetry would be have to be in a specific spot. But as long as you state the reflection, that's fine. Yeah.
What is that mark in the bottom left of the big triangle? Is that a mistake?
Bottom left. Oh yeah. I think I was going to start putting parallel lines or something. So that was just a little glitch there. Didn't get completely erased. Okay. So now it says state the sequence of transformations. All that was really was a reflection. Now here's the problem. I forgot to put. I forgot to put which one was the original and which one was the new one.
I'm guessing it's the smaller one.
So in this case, is it the dilation? Is it an enlargement? It's an enlargement, and it's a reflection. Okay. Now you guys are going to have to name a triangle with the letters. So you're going to have to pick letters. So let's say I pick C, D, E, or that.
And we can do that in any order we want.
Any order we want,
As
and
long
you
as
can
they
pick
match.
it. And then over here, let's say I pick F, G, and H. Yeah? For that other vertex. Be very careful. You have to tell me the two different similarity statements that you can write. So I'm going to write one of them. Triangle, okay, HGF, let's say. So it doesn't matter how you start it. But after that, the next one, though, has to be specific. So it's BCD. So since we started off with H, notice that H is opposite 135. That's the biggest side, isn't it? H is opposite the biggest side.
Yeah.
So we need to look at the small figure. Which one is the biggest side? 11, 12, or 15? So opposite angle of 15 is the letter E. So that needs to go first. ECD. So G, let me make sure where's G. Okay, G is opposite 108. That's the middle side, right? So I gotta make sure I do the middle side, which is 12. 12 is opposite C, so it would be C and then D. It'd have to be that order.
So that's all that we have to do for that.
That's one way to write it. You could write it another way. You could have said, instead of HGF, you could have done this, GFH. Notice I changed the order here.
Yeah.
But if I change the order here, I gotta change it on the other one though too. Yeah? What do you think the other order would be over here then? I can't say CCD.
CDE.
CDE. There's another way I could have written it.
HFG.
HFG. Okay, so if I wrote HFG,
It would be EDC.
EDC is basically this one. And then there's a, I was going to do this one, FHG like that. If I wrote FHG, that would be similar to what triangle? I guess I just
DEC.
yeah. So any one of those two is fine. Yeah.
You gotta do it. You gotta do it.
You just gotta give me two.
Okay.
Yeah. One of the questions might ask you just for one of them. Yeah. But you gotta make sure you pay attention to the letters that correspond.
Now, are you gonna give us the letters?
Yeah, this on the test I make sure I fix that. Because notice on some of these I didn't. Alright. Alright, let's go ahead and go to the next part. Alright, so in this question right here, you're going to be asked, did the person keep, is the picture similar to the original? So are the proportions the same? So here's what you got to make sure. What does this distance measure on the original? 3. Okay, what does this distance measure? 3. So that's a 3 by 3 rectangle. Okay. That picture was enlarged,
Well, it can't, it's not right.
or
Yeah.
square, that's a square. Thank you for correcting me. You are correct.
Because it.
Because all the sides, these are 3, these have to be 3. Yeah? Thank you for correcting me. It's not a rectangle. What are the dimensions of the enlargement? 3, 4, 5, 6. 6 by 6. Okay. Did the photograph get enlarged?
Yes.
Correctly.
It's correct.
Yeah. 3 over 3 and 6 over 6 both give you a ratio.
When it goes 5, 6,
did
it goes
I-
5, 5.
Does everybody agree it was 1, 2,
Well, I mean,
3,
it's 6,
4,
right?
5, 6?
Yeah, but you wrote 5, 5 on the top of it.
There's no 6.
There's no 6. It goes 1,
Oh,
2, 3,
okay.
4, 5.
Oh,
6.
okay, I got you. I got
Just the
you.
number.
I messed up right there, so thank you.
5, 5, 7. That's the new way.
1, 2, 3, 4, 5, 5, 6, 7, 7, 5.
For interesting pictures similar, could you just like draw an arrow to the drawing or obviously proportion?
No, you'd have to show me that work for the proportions that you checked.
Well, I mean, yeah, like we would
Yeah,
get that.
that's fine.
Now, what if it was 3 over 3 and 1 over 2?
3 over 3 and 1 over 2, then the picture was not proportional.
Like if you were trying to shrink the big
Yeah,
one
you're
to a
try-
wallet size.
To a wallet size, then there would be a distortion in the picture.
So it wouldn't be
Because,
proportional.
yeah, it wouldn't be proportional because the sides don't match the proportions of the original.
But you would still do the same thing.
Right.
But it would just be like 1 to the 0.0.
Right. Yeah. And later on, when you guys start getting older and you guys start making pictures of whatever it is, if the ratios of the original size image that you're trying to make doesn't match the ratios of the new, that's going to make the new picture that you maybe you're posterizing something, it's going to look distorted.
You know Windows doesn't know how to do this? When you like change your background picture, it just stretches the image.
Right,
It's not
it's going off the screen size, that's why. Because your
picture's
original,
not proportional to that screen.
your original image doesn't have the proportions of the screen size. Does that make sense? So that's where you gotta check. That's why it's gonna look weird. Yeah. Okay. And that's really where you see dilations, is when you guys are shrinking or enlarging. That's the main. Okay. All right. Could you tell me the scale factor?
It's
2. You see how quickly you guys are getting that now? Yeah. Could you do it algebraically? Yeah. New size was 6. Old size was 3. 6 over 3 is 2. All the sides were the same, so that's why I only have to check one. If all the sides are different, they should all give you the same scale factor. If they don't, something's wrong. Okay? So we practiced that a bunch of times. Remember all those scale factors, all the dilations, all the proportions. Okay. All right. All right. It says, describe the transformation that took place from shape A to shape B. It's an enlargement. It's a reflection. And, well, depending on where the line of symmetry would be, if the line of symmetry is here, let's say the line of symmetry is here and it reflects after it's dilated, then it's translated, right? So you'd have to state, it could be a reflection and a translation, or depending on the line of symmetry, it could just be a dilation with a reflection, okay? Could you tell me the scale factor? 4. 4? Now notice 2 of the sides are the same, 2s and 2s. Are there 2 that are the same on the other one?
Yes.
Yeah. So then you would go, the new size, which is the 8 and the 12, should be over the 2 and the 3. And 8 over 2 is 4, 12 over 3 is 4. The scale factor is 4.
What's equiangular?
Equiangular, all the angles of the figure are equal, and there's only one equiangular triangle. It's also equilateral then. Because if the 3 angles are the same, the 3 sides have to be the same. Yeah? Okay. Okay, we're okay here? You guys getting the hang of the scale factor and the proportions? If it's an enlargement or reduction, and then can you look at the picture? It was either reflected and translated. Yeah? Number 2, declare if the triangles are similar. On A, does everybody agree that if there's an angle here that's 30, this one is 90, this one has to be 60 degrees? Because those 3 add up to 180?
Yes.
So that means I have a little triangle and a big triangle that have 2 60-degree angles and a 90-degree angle.
And a 30.
And a 30. All I need is 2 of those to be the same, right?
Yeah.
So which theorem is it?
Angle
Angle.
That one.
Now, you are going to be asked to describe all the 3. So what does AA mean?
2 of the same angles means the third one has to be the same.
2 of the angles from one are congruent to 2 of the other. The third has to be the same. That's how you would describe it. Okay. All right. Everybody okay with what does AA mean? Yeah. Okay. Both of the triangles below are equiangular. So do me a favor. In the picture, this one, all the sides are the same, and all the angles are the same. This one also is equiangular. These angles that this one has are exactly the same over here. It's just a bigger image of it. Now, do you guys agree one of them is a miniature version of the other one?
Yeah.
So the sides over here are all equal to each other, but they're not the same as this one, because this one's smaller. Yeah? Okay. And we could say this is the original, this is our new image.
And that could either be side angle side or side side side.
Yes, you could do side angle side or side 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 on that. Either one of those two.
On the a drawing, wouldn't we have to put 2 lines on the angles to show that they're
No.
different from the
All these angles are also 60. Because in an equiangular triangle, there's only one equiangular triangle, and they all have to be 60, 60, and 60. That adds up to the 180. Even the one that's small, it's still 60, 60, 60. It's just a miniature version of it. It doesn't matter if the triangle is so small. Those angles inside don't get smaller. They're just proportional. The angle still should add up to 180, or even if it's a miniature triangle. Yeah. The big triangle, you can make a huge triangle. Those angles still have to add up to 180 in a triangle. Yeah.
You would just, your lines would be proportional.
Yeah, all the sides would have to be proportional. That way, that's how you would know if they're similar. Yeah. All right, so this one, you guys agree you could use side, angle, side, or side, side, side? Now, does everybody understand how to explain side, angle, side? Because we already did angle, angle, right?
When two sides, when you have two side lengths and an angle.
And the angle has to be in between the two sides. And you got to make sure you understand the two sides have to be proportional. Because if the two sides are not proportional, then they're not similar, and you can't use side, angle, side. Does everybody understand that part? All right, what if you use SSS? What is that?
You have all three side lengths of that figure.
And all of them have to be proportional. That's how you would explain it. Does that make sense? Yeah? And you should have this throughout the other handouts with the notes, too. Yeah? Okay. Remember how I kept stressing out these three? Okay. That's going to be on the test a lot, okay? All right. Next one. This one actually gave you the triangle that is the original. It's PQR. So PQR to STM, is that enlargement or reduction?
Enlargement.
Reduction. You guys agree? This is PQR, and that one's bigger than the other one. So that's an enlargement, or reduction, I'm sorry.
They gave us 2 angles.
And they gave us 2 angles, so which theorem?
Angle, angle.
Angle, angle theorem. Okay. What would be the transformation?
Translation.
Reduction and the translation, because once you reduce this, the image is going to get smaller, right? But then notice it's not inside of it, so it was translated as well. Yeah? So reduction and translation. Remember the types of transformations? There was translation, you're just shifting it in a direction. Reflection, and then the other one was rotation. Yeah? Okay. All right. Are all equilateral triangles similar? Yeah, all of them are, because they're all 60, 60, 60. Remember the one we just did that one of them was miniature and one of them was bigger? All equilateral triangles always are going to be 60, 60, 60. And it doesn't matter if it's a small version of it or a big version of it, they're still similar because the sides all have to be proportional. Yeah. Even the numbers of the angles will always stay 60, 60 for the equiangular. If it's equiangular, it's equilateral. Okay? Those go together always. Okay. All circles proportional. Yeah, because whatever the radius is, a circle only changes if the radius gets bigger. Yeah? And those radiuses would be proportional because the diameter of the circle only is as big as the radius of the circle. Yeah? All right. This one right here, it says to determine which one would you use, AAA, SAS, or SSS? Which one? SAS. So you have to set up the proportions, check that they are equal. If they're not, remember the sides. If the sides are not proportional, then you can't state that they're similar. Yeah. Are the angles the same? Yeah. What if the angles were different? Then we couldn't you couldn't prove that they're similar because the angle has to be the same and these sides have to be proportional. Yeah.
With that, would you do 4.2 over 5 and then?
Let's see, 4.2 is the bigger of this one, and you could write it over the. If you write it over 5, now 5 is the smaller of these,
7.
so you have to write it over 7.
And the 3 over 5.
And then 3 over the 5. You see how you're keeping bigs with bigs, smalls with smalls? Yeah. And you could have also done this. You could have said 4.2 over 3, because those two sides are on the same figure. Then you would say on the other side, what would you say?
7 over 5.
And you got, and however you check that, if those triangles are similar, then those decimals have to be the same. Yeah. oops, I wrote 4.5 over here. That's supposed to be a 4.2. Nobody caught that.
Yeah, it's 0.6.
Yeah, 0.6.
So they're still the same. So do you see there's a couple different ways you can set up, but you gotta keep it consistent. If you're choosing one from this one and one from the other one, make sure they're both either the larger ones or the smaller ones or the middle ones.
Yeah. Can you only do that if the angles are the same?
Only if the angles are the same, because and remember the angles gotta be in between those two sides.
Yeah.
And if those angles are the same, then it's possible that they are similar. You just gotta check that the sides are proportional.
Now what if the angles weren't the same?
Then you can. And you still have these two sides?
Yeah.
Yeah, you couldn't, because it doesn't matter that the sides are proportional. If those angles don't match, then something's wrong with the triangle, because we don't know what this third side is. Okay. So this one would be which one of the three? AA, side angle side? You guys getting the hang of that? Because that's going to be on the test all over the place. Yes? So AA, side angle side, and side, side, side? Yeah? Okay. That's all over the place. Okay. All right. Over here, when they ask you what's given, you got to look at the picture. Okay?
So I got stats 39 over 13 and 12 over 4.
Okay, so we're gonna, before we prove by using side angle side, we gotta prove that the sides are proportional and there's an angle that's congruent. Is there an angle that's congruent?
Yes.
Which one is it?
Angle A and B.
Angle A is congruent to angle B. You would have to label that. Does that make sense? Now, do you notice I put side, angle, side right here? I really should have put this here in the middle because isn't the angle?
Yeah, I was gonna say it's
Yeah.
the bubble.
So I'm gonna put what the sides over here that I'm gonna say. Yeah. Because I'm using side angle side, I really should have wrote that here in the middle. Okay, so I'm not gonna waste time with that. You understand? With that, really. Okay. Are there sides that are proportional?
Yes.
So give me one pair of sides.
13 and 39.
13 and 39, and they should equal the same as, what's the other pair?
12 and 4.
4 and 12, okay? 13 over 39, give me a decimal for that. 0.3, 0.333, repeat. All right, and then check 4 over 12. Same, okay.
I did it larger.
That's fine, larger to smaller should have given you then 3, I think. Yeah. Now the only thing that would make a difference for that is if
one was A.
if there was an enlargement or a reduction. Yeah, that would change the thing. So now here's the only thing left that you'd have to finish. It's right here.
Side angle side. Or no?
You already put side angle side. Now you just got to state triangle. Let's say ACB. Let's just remember the other one. There was like 5, 6 different ways we could have written it. Okay, but I chose ACB.
DFB.
So you think DFB. So let's just check. Angle A and D should be the first one since A was stated first. Yeah? Everybody agree?
Yes.
All right. And then let's check C. C is opposite the smaller side. Notice that? So we got to make sure that F is opposite the smaller side, which is 12 is smaller than 39. Yeah? This is going to be critical, guys, that you get that right. Because if your lettering is wrong, I have to mark it wrong. Okay? You guys with me right there? Yeah? Alright. This one, are these two triangles, do they have similar ratios? No. The ratios are not the same.
It puts it in the question again.
Yeah. Does this mean the triangles are similar? By side similarity, that means all three sides? No, you can't use angle side, or you can't use SSA. And here's the rule. You can't say this in my class.
Why not?
You can't use angle side. You can't do that.
That's a good way to have them memorize it, though.
Yeah, you can't say that.
Everybody focus. We're gonna learn about this.
You can't use angle side. See why? Can't say that. Okay. All right. Given AB is parallel to MC, so you should have drawn this extra set of arrows here. Everybody see that? All right. In the picture, you're going to have to prove that these two triangles are similar. Okay. So that means you have to prove that angle A is congruent to angle M. Angle G is congruent to what angle?
Wait, so those are parallel?
Yeah, it's stated already. It's given. Vertical angles. Angle G is equal to itself, isn't it?
Where is it given?
Right here in this question. In the question, it's
Two
stated.
lines
When you read the question, it's given to you.
It says given that AB.
Is parallel.
Oh, that's what
That symbol means parallel.
Okay, see, I didn't know that.
Okay. So just remember, there's two bars like that. They're telling you parallel. Okay. All right. And now you guys know what this symbol means right here, right? That's similar.
That one up there.
That one is congruent. And remember, they're not the same. You can have equilateral triangles that are similar, but not congruent. You can have
It would
equilateral.
be like 5 equals 5, but similar would be 5, and the other one's like 10, the other triangles.
Now here's the thing. Triangles can be congruent to each other. That means they're exactly the same size and they're exactly the same shape. If they're exactly the same size and shape, they can also be considered similar, but you can't go the other way. You can't say if they're similar, then they're congruent. Does that make sense? Okay. All right. Does everybody agree angle G is equal to itself because those are vertical angles? So you would have to state that. Those are vertical angles. Why is angle A congruent to angle M? And angle A is right here.
Corresponding interior angle.
Corresponding. Now, those are two different types.
Yeah, it's just
AGB. Oh, okay. A and M. Does everybody realize that these two angles here are alternate interior angles right here? And these two angles over here are alternate interior angles. And if lines are parallel, those angles have to be equal to each other.
Okay, so wouldn't they be corresponding exterior angle?
No, those, again, the corresponding, for example, corresponding angle to this one right here that I'm going to shade right here would be this one right here. Does that make sense?
yeah.
So because when you do corresponding, it's like you're cutting one image out and you're putting it on top of the other one, and they should match.
Okay.
Yeah.
So what would angle A are we?
And so I colored that in here. So I erased it. Do you see this angle over here with the 3 arcs?
Yeah. Those are corresponding.
That one is corresponding to this one over here. Okay.
Yeah.
But the one that has the 3 arcs and this one that has the 3 arcs, those are alternate interiors. You just have to ignore this other line. Okay? Alright. Alright, I'm gonna move on because I want to get the test started. Determine if the triangles are similar. For this problem right here, what can I use to prove these are similar triangles?
40 in the other line.
This 40, what does this symbol mean here?
That area will be better.
They're the same. These two are 40.
So then the other one must be 40.
So these are 40. Which theorem is it?
Angle, angle.
Angle, angle. Okay. All right, how about this one right here? Side angle, side angle. The angle's the same. Yeah. You have to make sure that the sides are proportional. Okay? If they are, then you can use side angle, side. Cross out this one right here. Cross this one out. Yes, cross that one out. You didn't have to do that one. All right, and then these last two, real quick, so I'm going to start the test in a minute, okay? Does everybody see the last, this one right here, 5 and x are corresponding to the picture?
5x over
5 over
x
x,
over
7 over 14.
14.
Yeah.
Oh, it looks like 24.
All right, but do you understand how you can set that up?
Yeah.
All right. And then, just real quick, what's the, does everybody see the vertical angles right here?
Yeah, right.
All right, so if I use x over 1232, what should I set it equal to? Now be very careful.
410 over 308.
Perfect. Other than that, the cross multiplying, you guys should be good at that, yeah? Yeah? Right. We did have handouts that we did throughout the unit. The unit was fairly quick. Other than that, we're going to take the test. And, yeah? All right. Justin, I'll have you move right here, Justin.
Okay.
Right here. Let's see. Connor, there, and Alexander.
Your turn, folks.
Okay. All right, we're going to start the test. Please read the questions carefully and no talking. Oops,
Oh, man. Oh.
So, majority of them are asking you for the scale factor. Is it an enlargement or is it a reduction? What's the, check the triangles are similar. Tell me, is it a angle angle or is it side angle side? Side side side. Okay.
Is this picture on?
No. It just has the box inside of it though, on that first one. So number one is asking you, is it a reduction or an enlargement? And then what's the scale factor?